So first, I have to set up my clicker. Right. Go. All right. So some announcements. As you know, we have a midterm tomorrow. Homework 5 was released on Tuesday and is not due tomorrow. It is due on Monday. So you have an extra weekend to work on it. However, if you haven't at least looked at Homework 5 by now, I strongly suggest you at least look at Homework 5 because the material will be on the midterm. Okay. So midterm tomorrow, look at the website for your room assignment. So depending on the first letter of your last name, you're going to go to a different room, one of 3 rooms. Okay. You must bring a student ID with you to the midterm. Let's see. There are 4 hours of lecture attendance required this week, but coming to the midterm will be 2 of them. Okay. The last office hours before the midterm are today from, I believe, 3 to 5 p.m. Okay. So last office hours today, 3 to 5 p.m. Location has changed to 367 Corey instead of 258 Corey. So make sure you go to 367, not 258 for last office hours today. No office hours tomorrow, because that'll be after the midterm and we'll be grading. Any questions? Cool. Let's get right into it. So let's start with a quick review of tables. So we know that tables are a collection of columns, right? Each column is an array containing some values. We have some methods to work with columns. We have, for example, with columns, dot column, dot select. These methods all view tables as kind of a collection of columns. So with columns adds a new column. Dot column grabs a column as an array. Dot select says pick out only these columns for a new table. Okay. There's another way to look at a table, which is a collection of rows. Okay, so each row refers to kind of one entry, one entity in my data set. We have some methods for working with rows, such as where, take, and sort. So these 3 methods all say, my table is a collection of rows. Dot where will only select out some rows. Dot take only selects out rows with certain indices. And dot sort says sort my rows. Okay, so 2 different views of looking at a table. Roughly speaking, most table methods are grouped into these 2 categories. Okay, one for columns, one for rows. Depending on the problem you're working on and the question you're trying to answer, you should try to divide up the methods in that sense and then pick out methods from there. Okay. So I have some pro tips because I get these questions a lot. So I don't get when to use dot group. Okay. My hint to you is if you look at the problem and you don't really know whether you need group or not, you're trying it out and you find that you need multiple dot where calls. So if you need like, oh, dot where and then dot where and then dot where, if you need like a bunch of dot where calls, chances are pretty good you need to use dot group instead. Okay, because usually what happens is when you're doing multiple dot where calls, you're trying to like group together parts of a column. Okay, so multiple dot where calls, especially if they're on the same column, that's a pretty good indicator that you should use group instead. I don't get what to use join. Do you need to combine 2 tables? This is the only method that we have for combining 2 tables together, more or less. So if you need to combine 2 tables, chances are pretty good you want to use dot join. I don't get when to use dot pivot. Okay, so my hint to you is if you don't know when to use dot pivot and you're using group and you find that you need to group by 2 columns at the same time, and you need the table to look differently from what it did before. So if you use dot group with 2 columns, you get the grouping and then like everything else as like the rest of your columns. If you need to use dot group with 2 columns and the format of the table is a little bit different than the format that we're asking for, then chances are pretty good you need to use dot pivot instead. Okay, so let me give you guys some questions. So with your partner, please work out on paper. Okay, so I'm telling you guys to work it out on paper because on the midterm, all you have is pencil and paper. You need to really be able to like write down this stuff on paper in order to be prepared for the midterm. Okay, so talk with your partner, but write down your answers on paper. Just write it all out so you get the sense of writing it down. Using this table called voters, which contains the state in the state column and the choice of candidate in the choice column. So in this case, there are 3 candidates. There's candidate A, candidate B, and undecided, which I've marked with A, B, and U. Okay, so only three candidates here. Everything else is just a repeat of A, B, and U. We have 50 states here and a bunch of rows for a bunch of voters. How do I find the candidate that won How do I find the distribution of votes for California? Go ahead.
Could use Delaware and just compare. It really just depends if you're like filling in or. Yeah, because I was trying to do where first, and then I was that would also give you and you could also use really? You're
All right, how many are done with the first question? Done with the first question? Raise your hand for me, just so I get a sense. Done with the first question. Done with the second question. All right, go ahead and take a couple more minutes. Make sure to write down your answer. Okay, write it down. You need to write it all out.
Well, actually, I guess.
Yeah, Elias? Oh, partial or full credit? Partial credit if you get close to the answer, typically. How about you ask me after, because it's a little bit hard to, yeah, let's do that.
Do you want to erase the second question?
Okay, so let's go over the answers. Basically, these questions are not very well defined because I did not say which type of thing I wanted. I just kind of wanted to get you guys thinking about it, okay? So it's a good question that you're asking, oh, do I need an array? Do I need a table as the end? Like, what do I need as my final result? That's the sort of thing you want to look for on the actual exam. Unfortunately, on these slides, I was not able to put in, like, calculate a table containing these particular columns or blah, 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 because I didn't have space on my slide. So I just wanted you to think about how you'd approach solving this problem. Once you have, like, the overall steps down, converting between types is usually adding, like, a dot column or, like, something else to it, okay? So how do I find a candidate that won? My approach here would be to say, okay, I want to look in the choice column and figure out which candidate got the most votes, okay? One easy way to do that, so let's say I wanted just a table where I can see the winning candidate. The way to do that, the most easy way to do that is to just group by the choice column. If I group by the choice column, I get a column, and then since I have got as a second column, that would be the easiest way to see just at a glance which candidate won. On the other hand, if I wanted to know like the actual string candidate that won, I'd have to do a little bit more work. I'd have to group and then sort by the count in descending order and take the first column, the first row of like the count column. The first row of the candidate column, the state column, sorry. Okay, so oops, didn't want to show you that yet. Okay, so that's how you do the first question. There are multiple ways to do it. The counts of each one. There's other ways of doing this problem. It just depends on. So usually on the test, we'll give you some hints as to how you should approach it. So you should look forward to that. But usually, if there are multiple ways to do it, you can use either one as long as it gets you the same result that we're looking for. Okay. Any questions about that first question? Cool. So the second question, the distribution of votes for California. Typically, when we want a distribution, we want like A, B, and U, and the counts for A, B, and U just for California. So in that case, it's not too much of a stretch after the first one. Before you do the group, you do a .where. Okay, so before you do grouping on voters, you do voters.where state is California. That gives you only the rows for California. And then you can group. You can call it .group on the choice column. That'll give you the counts for the candidates for California. Okay, so here it is. So again, if you actually wanted that candidate here, you have to do a little bit more work than voters.group choice. I'm just showing you like the bare minimum answer to get the candidate that won. Here's how you get the distribution of votes for California. Any questions? Yeah.
Should there be a r dot equal to right there, or is it okay to just put CA?
Yeah. So should there be a r dot equal to here, or is it okay to just put CA? So r dot equal to and just putting the string here that you're looking for, those are equivalent. Okay. So if you just put CA here, it's a shorthand for r dot equal to CA. Otherwise, you have to do r dot less than or whatever you want to do. Yeah, Elias? Can you do that with like integers or like numbers? That's right. So you can do it with anything. You can do it with integers. You can do it with Booleans. Anything you want can go here. It'll just be translated to r dot equal to whatever that thing is. So on the test, if you're like running out of time, maybe this will help you save a little bit of writing. You can just put the value here instead of doing r dot equal to the whole thing. Okay. All right. So let me move on to sampling. So what I'm going to do now is I briefly went through tables. I'm going to briefly do sampling. I'm going to spend most of today working on like hypothesis test, choosing a test statistic, choosing like the direction of the alternative, all that stuff. Okay. So quickly go through sampling. So to recap, the point of sampling is that it lets us approximate probability distributions. Okay. The thing to remember here is that the larger the sample, the more the distribution will look like the population's distribution. In a nutshell, that means if I have a die and I roll it 10 times and I plot the distribution of like 1, 2, 3, 4, 5, 6, it might not look very much like the population distribution because of random chance. But if I roll my die like 1 million times, chances are pretty good the distribution of the faces will be almost uniform to match the population distribution, the actual probability distribution of the faces. Okay, so the larger the sample, the more the sample resembles a population. When we have one sample, we can take that and get one estimate of a parameter. Okay, so for example, in the enemy planes, when we were trying to find like how many planes the Germans had, if we took one sample of, let's say, 20 planes, and let's say we're taking the max, so we take the max of the serial numbers for those 20 planes, that gives us one estimate of how many planes there are overall. If we want to find the distribution of that statistic, we need multiple samples. Okay, so if we have multiple samples of 20 planes, we can compute multiple estimates for that maximum serial number and get a distribution. Okay. So let me give you a question. Let's suppose that I roll a fair die. Okay. If I roll a 1 or a 6, I pay the casino $1. If I roll a 2 or a 5, the casino pays me $1. And if I roll a 3 or 4, nothing happens. Which is an empirical histogram of my net winnings. I hope you guys can see it in the back. So pick the histogram that shows what I would get if I were to play this game a bunch of times and get how much I won, and then play it again a bunch of times and get how much I won, and plot my winnings on a histogram. So unfortunately, it looks like these numbers here are pretty small. This right here is 0. This right here is 0. This is 0 here, and this is 0 here. So zeros are in the middle. Try it out with your partner. Talk about it.
So if you roll a dice, say 60 times, maybe 30 times, the most likely option out of everything else, but it's not very likely by itself. Is to get 20, 20, 20, or 1/3 of each of these, which is a negative of $0. So that means that this term should be centered around $0. But that would be the most likely option, and then belt everything out in details. So that'll be the second one.
Well, I mean, he's only rolling the dice once, so that means that there's likelihood of
Let's say that he rolled the dice 60 times. Okay, so I roll the dice 60 times and then I play the game, and I find out how much I win. Sorry for the confusion there. Roll the dice 60 times.
Or not one.
It would have changed. It would be different though if you had rolled it like if the number of times you rolled it was, then it would be a larger distribution.
All right, so let's talk about it. Okay, so in this game, here are like my outcomes depending on what I roll. If I roll a die 60 times and get like give $1, get $1 sometimes, blah blah blah, I expect that in 60 rolls, I pay about $20 and I get about $20, and this is nothing, right? So that means that my overall net gain should be about 0. Okay, all these histograms. This one is not centered at 0, so we can roll this histogram out as like what my empirical distribution will look like. Okay, so if I play this game, I should get around 0. I play it again, I could get above 0 a little bit. I play it again, I could get below 0 a little bit. But chances are I'm going to get most of the time 0 net winnings. Okay, so only this histogram right here says, it looks like you're pretty unlikely to win like $30. Whereas this histogram says you're winning $60 is equally likely as winning $0. Right, so that's the differentiation between histogram 1 and histogram 2. We know that it is possible to win like $5 more. It's not too hard to win like $5. It's not too hard to win maybe like $6 or so. This histogram only goes from -1.5 to 1.5, so this histogram is not correct either. Only this histogram says your most likely outcome is winning $0, but you can lose a little bit and you can win a little bit. Okay. So as perhaps a challenge question, and probably beyond the scope of what we're looking for, is how would I change the game so that my empirical histogram looks like this one? So how would I change the outcomes or the dice rolls of this game so that I get about $20 every time I play in 60 rolls? Okay, so maybe you can think about that one as a challenge question. Otherwise, let's take attendance. Okay. And open it.
I'm here, right? What is this? How does this mean?
All right. So let's talk about hypothesis testing now. Just to briefly recap. Oh, this wasn't supposed to appear all at once. Pretend that they appear one by one. Okay. So the recipe for doing a hypothesis test is state your null and your alternative. These always depend on the context, okay? So depending on the question you're asking, those will change your null and alternative. You have to read the question that we're asking you to figure out, okay, the alternative is like greater than, or it's not equal to, or it's less than whatever I think the actual value is, okay? So these depend on the context. Next step is to look at your alternative hypothesis and pick a test statistic, all right? Based on your alternative, you're going to pick a test statistic that matches your alternative, okay? We're going to be doing some practice problems on this particular one, which is why I bolded it. After that, you want to assume your null is true, and then simulate your statistic by pulling random draws, assuming that your null is true. Okay, so we're going to be working on that as well. Finally, you want to mark your observed test statistic on your empirical distribution of your statistic, and then compute the p-value, which is the area equal to what you observe, or more extreme, in the direction of your alternative hypothesis. Okay, so that's a brief recap of the steps to take. I want to do some practice now on picking a test statistic, because I believe that's where I got a lot of confusion yesterday and this week in general. Okay, so here's some problems for you to try. So if my alternative hypothesis is Sam cooler in the class? So technically this should be Sam is cooler in the class. That would be a hypothesis. This would be a question to ask. Okay, I can also ask, is Sam less cool in the class, or is Sam just different? Pick a test statistic, and then pick a direction to look in my distribution. Okay, so you should say something like, oh, I would take his coolness times 2 squared and look in the positive direction. Or I would take his coolness, like square root of his coolness, and look at his negative, and look in a negative direction. So figure out what test statistic to use and what direction to look in. Try it out with your partner for these 3 problems.
I think it's the first 2 is maybe like or take his coolness as some class average and look at that distance. This is from class average. For the last question, even for the second question, it's less cool than class. That's what we're trying to find that distance. You're trying to do class average this class. Flip on the first question. So for our last one, it's either one of the 2, and my absolute value.
I was thinking it was like so then you compare where each score.
Yeah, we can do that.
That would work because I would I agree with that. But what I'm saying is, like, you have to first all the students, how different is there other students different?
But I would say you're saying cooler. Stop it. Stop.
So that's the only thing that's like less cool would just be.
All right, so let's talk about it. Okay, in this case, if I'm just trying to find is my coolness level greater than everyone else's coolness level, I can just take my coolness by itself and look in a positive direction. Okay. If I want to figure out whether I'm less cool than the class, I take my coolness and look in a negative direction. That's all I'm willing to do. Finally, if I want to figure out whether I'm just different from the class, I want to find the distance I am from the average of the class, which I'm going to say is 50. So here I would say absolute coolness minus 50 and look in the positive direction. Okay. Any questions about that, Alex?
When you say look in the negative direction, what are you like hoping to find essentially?
Yeah, so basically the idea is in class I did the coolness thing where you like raise your hand, blah, blah, blah. So I said, okay, if I'm trying to figure out whether I'm cooler than the rest of class, what I'm going to ask is my coolness 85? How likely am I to get that or something more cool from the class? Which means I ask you, how many of you guys chose 85 or higher? Right? I asked you that question. People raise their hand. I counted how many there were. On the other hand, if my alternative hypothesis is I'm less cool than the class, then what I'm going to do is I'm going to say, okay, take my coolness, which could have been like 10, and say, okay, everyone who got 10 or below, raise their hands. So first I asked, so here I said 85 or above. Here I said, oh, my coolness was 10. Look at my coolness or below. That's looking in the negative direction because I'm going downwards. Okay, so I look either upwards or downwards depending on my question. It's more likely than not you're going to look upwards because sometimes you're going to be cooler, sometimes you're going to be less cool, sometimes you're going to be just different. But both these cases need a positive direction. So both this case and this case need a positive direction because when you take the absolute value, you only get positive, 0 or positive values. Yeah, good question. Any other questions about this? Yeah.
If you know what direction to look in, how would you actually determine if you are cooler than the class?
Yeah, so it's Jared.
Yeah.
Jared asks, how would I determine whether I'm actually cooler than the class? So that's where you draw your sample. So you simulate drawing samples, plot the distribution of your statistics, and then say, okay, what proportion of my samples has something cooler, what has something equal to or more cool than me? And I would say, okay, that is my p-value. So the p-value, the computing of the p-value is a precise, like, how to quantify how much cooler, quote unquote, I am than the rest of the class, less cool than the rest of the class, roughly speaking. Okay, so this is just a setup for the problem. This is, again, like if I go back to my recipe, it's kind of like this step right here. I'm just looking at the second step right here. I still have more steps to do in order to actually figure out, okay, do I conclude that Sam is cooler or not? Cool. So let's try out some more. So here I have my coin is unfair. That's my alternative hypothesis in 20 flips. Here I have the pea plant example, proportion purple. The proportion of pea plants that are purple is less than 75%, so try that out. Finally, I have the jury is unfair. So if you recall from our jury panel example, we're looking at ethnicities. Is our jury panel fair or unfair? How would you choose a test statistic for each of these 3 alternative hypotheses? Try them out. These are a little bit more complicated than the one I just described.
First, I would do the absolute value.
Add the number of either heads or tails by 20, by 10. So try whatever that proportion is by 6 or take stuff 5% and try out the proportion of the same class. Jury is unfair. Just like well, for TBD, it's just like the other TBD is a big class thing. Just like the other ones. We're not talking about the variables yet. We're not talking about it.
Three out of 4.
Oh no. How do you decide? Well, simulations. Look at all the TBDs on that bell curve. See where you observe the stands. Nope. Same as just like, do we need a cutoff for distance? Do we need a cutoff for the number of heads minus 2? No, we just need a cutoff for a p-value. We're looking for a proportion of that either observed or more in the direction of the alternative. We can only judge it based on like the data we're given. The TBD might be something like well, it's not. Think of the TBD as like just like the proportions minus 75 or 75 minus the proportion. We find it for the p-value, that's just the proportion of the test statistics or more in the extreme direction, more in the direction of the alternative. So not a cutoff for the TBD by itself, but a cutoff for the p-value.
All right, so let's try it out. So If my coin is unfair, what test statistic would I want to use? Any takers? Are you raising your hand, Alex?
Yeah.
Okay, what do you think?
Number of heads minus 10.
Number of heads minus 10. Close. So if I'm looking at coin is unfair, I need to make sure that I count for whether the coin has more heads or less heads. So I need that absolute value there so I can get the distance away from what I expect. But yeah, close. Heads minus 10, absolute value that, and look in a positive direction. Okay? Yeah, question?
Could we, instead of 10, use the number of tails?
Yeah, so if you're saying, oh, okay, instead of counting heads, I count tails, what would you do in that case? Let's suppose I'm counting tails instead of heads. I could do it either way. What about tails? What do you think?
No, I mean if we do the absolute value of the number of heads minus the number of tails.
Absolute value of number of heads minus number of tails. Let's see. So would that allow you to measure a difference? I believe it would. Yeah, so you could also use that because if you get a lot of less heads and do like 1 head minus 19 tails, you get a pretty big number in the absolute value. If you get a lot more heads, then you get like 19 heads minus 1 tail, then you still get a big number as your test statistic. That seems like a valid one to use. Yeah. Yes?
Should we like divide it by 2 then?
Should I divide it by 2 if I do heads minus tails? Divide by 2. It doesn't quite make a difference in that case because what you're doing there is like you take your distribution and you take your observed value and you look at the area. If you divide everything by 2, you're just like shrinking everything together, but the area is still the proportion in that area is still the same, right? Similarly, I could take this test statistic and subtract 100 from it. So I could take this whole thing minus 100. That wouldn't change my result. It wouldn't make my hypothesis test invalid because what I'm doing there is I'm taking my distribution and my observed and just moving it all the way down and then still taking the area, which will be the same before and after. Yeah. Kevin.
So why did you choose to subtract 10 here?
So why did I subtract 10 here? Yeah, that's because I expected to see 10 heads in 20 flips if my coin was fair, right? So if my coin was fair, I should expect 10 heads. Then I want to figure out how far away from my expected value did I actually get. This gives me a measure of how far away I am from my expected value. Yeah, again?
So going back to the misinterpretation that happened there, because if you were doing tails minus the number, it would be the same thing, right? Tails minus the number of tails you expect to see.
That's right. So if I had said, I want to count tails instead of number of heads, I could just swap tails in for here and count the number of tails. That would still give me a measure of how different my results are from what I expect. Cool. So for proportion of purple flowers is less than 75%, what I want to do there is take my proportion of purple, so purple divided by total. Now again, I didn't give you these variables, so don't worry about like whether you did the purple divided by total correctly or not. What I want you to take away from this is I can just take this proportion of purple by itself and not like look at anything else. Just take that proportion and look in the negative direction. Okay. So if I had said, okay, the number of purple flowers is in the variable purple, and the total number of flowers is in the variable total, then I would want to do purple divided by total. What I'm really computing here is just taking the proportion by itself, not doing anything special to it, and just looking in a negative direction. Whereas here, I do have to take heads minus expected value and then absolute value it. Okay, so here proportion is by itself is fine. Questions about that? Yeah, so why do we look in the negative direction? That's because my alternative hypothesis is that the proportion of purple flowers is less than 75%. So if I say, okay, the proportion of purple flowers is less than 75%, I want to take what I observe, I find out how likely am I to get my value or anything less than my value. For example, in the coolness case, I asked, okay, am I less cool than the rest of class, which means like kind of like coolness less than rest of class, roughly speaking, right? I said, how many guys got my coolness or below? I'm looking in a negative direction because of the way I asked my question. In this case, my alternative hypothesis is proportion less than 75%. That means I look towards 0. Any other questions? Okay, so what about jury is unfair? Jury is unfair. In this case, I want to use a TVD. Why do I want to use a TVD? It's because when I'm looking at jury panels, I'm looking at distributions. Okay, so in my original population, I had like, let's say 15% Asian, 10% African American, 10% everything else, whatever. I have the distribution of ethnicities. I want to compare that to my actual panel's distribution of ethnicity. So I'm comparing two distributions. Whenever I'm comparing two distributions, I usually want to use a TVD. Okay. Here, I'm not comparing two distributions. I'm comparing two proportions. Here, I'm comparing two distributions. TVD is the way that we compare distributions. So I just want to find a TVD between the population and what my sample got. That is my test statistic. Okay. Any questions about that one? Okay. So we work on our hypothesis test question. We pick our null and alternative. We pick our test statistic. Now we need to do the second hard step, which is to actually simulate draws. Okay. So we're going to simulate draws. I want you to try this out. Okay. So write the code to simulate one test statistic for the following null and alternative hypotheses. If Mendel grew 900 pea plants and got 705 purple flowers, my null in this case would be 75% of pea plants will have purple flowers. My alternative is that greater than 75% will have purple flowers. How would I write the code to simulate one draw? Try it out with your partner. This takes about like 3-4 lines here. So it's not just like a one-liner. You actually have to think about it. Think about the steps you need to take. Go ahead. Give you guys a couple more minutes to work on this. So if you look at this and you're like, I don't know what I'm doing, the question came straight from lecture a couple days ago. So the answer is in lecture if you want to take a look. If you look at this and you're like, I still don't know what to do, it's a good indication that maybe you should review. Okay? Go ahead, take a couple more minutes. Okay, so how would I do this? Okay, so the first thing to do is to note that when I'm doing simulation, I'm doing a simulation assuming the null is true. A test statistic, I look at my null. Okay, when I'm choosing a test statistic to use and a direction to look in, I'm looking at my alternative. When I'm simulating a test statistic, I'm looking at my null. Okay, I look at my null, and my null says 75% of pea plants will have purple flowers. Okay, so that means that I want to make, what I want to do is I want to say, okay, I really did have a 75% chance of getting a purple flower, and I grew 900 pea plants. What proportion of my pea plants had purple flowers? Okay, so what I'm doing is I'm taking my null, I'm simulating another sample. Okay, so assume my null is true, grow another 900 pea plants, look at how many of those are purple, and then I can say, okay, based on this alternative hypothesis, I want to choose my test statistic as the proportion of purple flowers. Okay, so what I'm going to do is first, so here is 3 purples in an array and a white, which means that if I do np of random.choice from that array, I'm going to get purple 75% of the time. I'm going to take a sample of size 900 from that array. So this is my sample. This is me pretending to be Mendel. And I have 900 more pea plants. What I'm going to do now is look at the proportion of pea plants that were purple. So count up how many of those are purple divided by how long my sample is. Proportion of purple flowers in a sample, assuming that the null is true, that is one test statistic for my null hypothesis. This a bunch of times and compute the distribution. The distribution of my test statistics will give me, I can compute from there an empirical p-value for this hypothesis test. Any questions about that? Yeah.
Why are you doing length of sample instead of divided by 900?
Yeah, so Melissa asked, why did I do length of sample instead of divide by 900? Both of those are the same. Yeah. This is just like the more common piece of code that you see because sometimes the length of the sample will change for different questions. And this piece of code basically is just a one-size-fits-all. But in this case, I am doing divide by 900. This right here will evaluate to 900. Good question. OK. Any more questions? Yes? That's right. So I'm trying to pretend to be Mendel, right? So when I'm drawing a sample, I need to draw a sample as the same size as my original sample, which is 900. Because I'm trying to see, OK, in pea plants, in samples of 900, what proportion of those are purple, usually? OK.
You briefly mentioned what goes after what would go after the 3 lines of code. Can you elaborate on that a little bit? Yeah.
So what happens after we do this? So basically, this gives me one statistic. So this gives me, OK, I grew 900 plants. Let's say 77 of them were purple. OK, so 77 of them were purple. I want to repeat that a bunch of times. Right. So I want to repeat this a bunch of times, get a bunch of test statistics. I can put those on a histogram and look at what proportion of them were of my observed value or more in the direction of my alternative, which in this case would be positive. Okay. Any more questions? I have one more of these. All right, let's try it out. So write code to simulate one test statistic for the following 2 hypotheses. I roll a 6-sided die 24 times and got no 6s. The null is my die is fair. The alternative is my die is unfair. Try it out. Okay, so try this. Before you do any writing, talk over with your partner the overall steps, okay? So just like in the previous example where we had to do null, take a sample, and then compute a statistic, talk over each of those 3 steps with your partner. How would you do this? How would you do this? How would you do this? Get the high-level steps down. Write down the code, okay? So you should always get the high-level steps down before you start writing the code.
And then recording, and the next one we recorded. And then right, you count the number of hits that are divided by right, yeah. So you're saying like roll it, count the number of sixes before somewhere. So then we would store like all the number of constant sixes, and then we do what you say. Anything that breaks like the number of times your sample breaks. Yeah, that's what I thought the P value is like. I thought the P value was it's like not P like 0.95. That means like 95% confidence that the value is within. I think that's like the English definition. I feel like you just do it. I look at it's like yeah, I'm not really sure. So the formula, I think it's okay, so it's we would look at all the times that it wasn't zero. Right, and then we would divide it by. Oh, that would give you the probability that it actually occurs. That makes sense.
Or less.
So like if you got if you rolled this 1,000 times, let's try to do 1,000 times, and you got like 1 time, you got 0 6, then you want 1,000. Interesting.
How many of you guys are done writing your code? Okay, let's do 1 more minute. 1 more minute. So, roll 6-sided die 24 times. I got no 6s. Knows my die is fair. Alternative die is unfair. So based on my alternative, what do I want to find? I want to find how far away my sample is from my expected value of 6s, right? So if I roll a 6-sided die 24 times, I should get about 4 6s. I expect about 4 6s because each face is equally likely. So about 1/6 of these 24 should be 6s. So I expect 4. I want to find out, OK, roll my die another 24 times. The way I was from my deviation from my expected value, which was 4. So what I'm going to do there is say, OK, the expected number of 6s is 24 divided by 6. In the null hypothesis, each face is equally likely. So here's the numbers 1 through 6. Each face is equally likely. Then I give a choice and roll my die 24 times. So here I'm taking my die, rolling it 24 times. Here is my sample. From my sample, I compute a test statistic, which is this long thing, which is basically take my sample, find how many 6s there are, count them up, subtract the number of expected 6s, and then take the absolute value to find out my overall deviation from my expected. So it's long, but if you look at each piece individually, hopefully you can piece together what I'm trying to do here. Any questions about that? Alan?
Sample size always equal to the size of your observation.
That's right. So should my sample size always equal to the size of my observation? Yes. Because I want to figure out, OK, I rolled 24 times and got no 6s. If I rolled 60 times and got no 6s, that would be more suspicious than 24 times and no 6s, right? If I only rolled my die 10 times and got no 6s, that would be less suspicious than my, what my state is before. So the number does matter. You do need to get this number in your sample. Amanda? Yeah, so why is my expected 24 divided by 6? It's because if I roll a die 6 times, I expect about 1 6. But 12 times, I expect about 2 6s. 24 times, about 4 6s. Yeah. Last question? One last question? Yeah, go ahead.
Why can we not just use the numbers and use like the as a
Yeah, so why can't I use a number of 6s? It's because of my alternative hypothesis. The alternative hypothesis says my die is unfair, but it does not say what direction it's unfair in. So I could get less 6s than my null, or I could get more 6s. My die could be biased towards either direction. Because it could be biased towards either direction, I need a measure that gives me, I need a measurement of how different it is from my expected in either positive or negative direction. The absolute value gives me that distance. All right. How about you ask me after class? Good luck on the midterm tomorrow. I'll see you.